Comilla, Higher Maths 2017, question number 7. In question 7 we're given A is equal to sec theta plus tan theta and B is equal to cos of minus 25 pi over 6. And in part A we want to find the value of B. Well, to solve part A, we have the cosine of minus 25 pi over 6 can be written as the cosine of minus 4 1/6 pi. But we know that the cosine of minus theta is equal to the cosine of theta for any angle theta. So the cosine of minus 4 1/6 pi is the same as the cosine of plus 4 1/6 pi. Now, if we draw a graph of the cosine, it repeats itself every 2 pi. So if we look at the cosine of 4 1/6 pi, that's the same as the cosine of 1/6 pi, because the cosine of 1/6 pi is the same as the cosine of 2 1/6 pi, which is the same as the cosine of 4 1/6 pi. Now, if it's equal to the cosine of pi by 6, then it's equal to root 3 over 2. So our answer is B is equal to root 3 over 2. Now in part B, we're told if A is equal to x, then show that sine of theta is x squared minus 1 over x squared plus 1. So to solve B, we're starting with x equals sec theta plus tan theta, and we've got to prove that sine theta is equal to x squared minus 1 over x squared plus 1. So let's start with the right-hand side, x squared minus 1 over x squared plus 1. Now if we substitute x is equal to sec theta plus tan theta, we have the right-hand side is equal to sec theta plus tan theta all squared minus 1 over sec theta plus tan theta all squared plus 1. But we have sec theta is 1 over cos theta, and we have tan theta is sine theta over cos theta. On the top we can change sec theta into 1 over cos theta and tan theta into sine theta over cos theta, and it's exactly the same on the bottom as well. So the right-hand side is equal to 1 over cos theta plus sine theta over cos theta all squared minus 1 over the same thing plus 1. Now we can multiply the top and the bottom by cos squared theta. This means the right-hand side is equal to 1 plus sine theta all squared minus cos squared theta over 1 plus sine theta all squared plus cos squared theta. And we can expand the brackets. On the top, the bracket 1 plus sine theta all squared can be expanded to 1 plus 2 sine theta plus sine squared theta. And the same can be done on the bottom. 1 plus sine theta all squared is expanded to 1 plus 2 sine theta plus sine squared theta. So we end up with 1 plus 2 sine theta plus sine squared theta minus cos squared theta over 1 plus 2 sine theta plus sine squared theta plus cos squared theta. These can be rearranged as 1 minus cos squared theta plus 2 sine theta plus sine squared theta over 1 plus 2 sine theta plus sine squared theta plus cos squared theta. And we can use sine squared theta plus cos squared theta equals 1. So we see 1 minus cos squared theta is sine squared theta on the top. The rest of the top remains the same. And on the bottom, the sine squared theta plus cos squared theta equals 1. We can simplify this. And we get 2 sine squared theta plus 2 sine theta over 2 sine theta plus 2. Now this factorizes. 2 sine theta is common on the top and 2 is common on the bottom. So we end up with 2 sine theta into sine theta plus 1 over 2 into sine theta plus 1. Now the 2's cancel and the sine theta plus 1 cancels. So we're left with the right-hand side is equal to sine theta, which is equal to the left-hand side. Now in part C, we have to find the value of theta when a is equal to the square root of 3 and theta lies between 0 and 2 pi. Well, to solve this, we have a is equal to the square root of 3. But we've already shown that if a is equal to x, then sine theta is equal to x squared minus 1 over x squared plus 1. So if we substitute the square root of 3 in the place of x, we get sine theta is the square root of 3 all squared minus 1 over the square root of 3 all squared plus 1. Now that gives us sine theta is equal to 3 minus 1 all over 3 plus 1, which is equal to 2 over 4. So sine theta is a half, which means theta is equal to pi by 6, or theta is equal to 5 pi by 6. If we put that in degrees, theta is equal to 30 degrees, or theta is equal to 150 degrees.